back. I realized now I have my whole little webcam section turned off. I did not intend to do that. I meant to have my little placeholder there for what we're going to do. This thing's still running, like the universe hasn't exploded, which is kind of a good sign. I think we'll do what we traditionally do at the halfway point now, which is to do a quick run through the code, remind ourselves of exactly how it works, and maybe add some more comments and stuff in there to make it even clearer. So we have some constants here. So the purpose of this time step is that we want to always update the physics simulation with the same time increment each time, and this allows us to do that. For stability and consistency, that's what that is. So the prototypes are a list of kind of, a body by the way is kind of a planet or a sun or any gravitational thing. So what we have here is a list of with those with the mouse. This is just so this is basically the whole actual state of the simulation. So we have the setup function, which runs once when the program starts. First thing here is just creating the window. Load some assets, create some prototypes. Create some initial stuff in there. So this is just used to handle the kind of time step. Calculating delta time, and this is to use to kind of accumulate time, and this handles like the overlap when the frames, when we're rendering, you know, the frames in the real world don't quite line up perfectly with these nice time steps we defined. If it's not an exact multiple. This is the actual sort of simulation section. So we do as many time steps as we can before, you know, until we've kind of done all the time we have to simulate, and then maybe a little bit left over, which we'll account for next time. So what we're doing is the reason we have two separate loops here is that we want to calculate all the gravity forces before we start moving stuff, because we don't want these calculations to account for like some old positions of objects and some new positions of objects. Probably a nicer way to explain that. If you watch the first half, hopefully that makes sense. Okay. Then this is just rendering here. So we kind of draw all of the planets. And then this is kind of they're not planets, they're bodies. This is just kind of the UI for placing new bodies here. So when the mouse is pressed, remember that position, and then what happens, if you look at the app again, is that you click something and then you drag to kind of set its speed, and then you let go, and then it fires off. So place position is where we started placing it, and then when it's released, what's happening here. It's a bit janky, we should probably look at the actual size of the body. I've just got an arbitrary threshold. If I'm within 30 pixels of like the center or something, it lets me delete it. I mean, that probably doesn't line up right. I can probably delete this without strictly touching it, but you know, that's probably okay. Just as a little, in this little demo here. Okay, then the actual simulation is fairly simple. Okay. So this is basically what that does. This now probably makes sense down here. So that's all that does. So we could do something more clever here, like only record the position, you know, not every frame necessarily. But you know, this works for now. Just draws a load of dots at our previous positions. Cool, and that does what we need it to do. What would be nice as well would be to pause the simulation, I think. So let's say when I press a key, when I press space, it's going to key space, then you just toggle the paused thing like that. I think what I'm going to do here is say if that will do what we need, I believe. Nice. The reason for doing that is because it's kind of nice to be able to say, let's place this, and then let's place this at the same time, and then hopefully we can have them. Oh, maybe not. If I place something like this, and then place something else like this, then hopefully they'll orbit each other. And the mass is really low on these things. I think that's probably why they're like barely affecting each other. And you know what, if I increase both their masses, then that's... Oh. I suppose because the force will like square, but the F because MA will just increase linearly. So yeah, so that, okay. Sorry, getting caught up in my own head there. Okay, next thing I think I would like to do is... So we've got this, right? That's done. It could be okay, but it's not like... This save and load would be fine, but it's not the most interesting thing. Manual control is cool, but I feel like doing the path predictor would actually help that. So this is kind of what I want to focus on next. So right now we have this kind of state, right, which is this list of all of these bodies, with their position, velocity, and so on. And then each frame we're kind of going in and we're like updating this to a new state. We're going in and changing all the values. If we want to predict the position of something, I feel like what we need to be able to do if we want to make a prediction is to like make an entire copy of this, and then be able to run like several steps of the simulation, like maybe hundreds or even thousands, without affecting the original actual update. But running this, over and over again. And then maybe, so what's the purpose of the simulation, right? We want to know what path something's going to follow in the future, so we probably need to, we create a copy of all of the planets and their state. We run the simulation update many, many times, and each time we probably remember the position of the object we're interested in, or objects we're interested in, so that we can then plot like a projected path for them all. So I think I'll maybe put this out into a new tab. Well, it's simulator, and I kind of want to take this code. Put it in the simulator. Just say so we're going to probably pass in a list of bodies. That's pretty much all we need to do there. Okay, and I'm going to say simulator dot simulate simulate is probably not the best name, maybe like step. more sense because it's applying one kind of time step. But what I'd also like to be able to do is to do this prediction thing, right? So and what's this going to return? I'm going to say a list of points. Just going to predict given a list of bodies. Probably given a body with the body of interest. Maybe we could do this for all bodies, but for now I think this works. And then say how many steps we're going to run for this. Right, so it's going to need to do a few things, right? So first it's going to have like the actual result. We know how big this is going to be in advance, so we can pre-size this. There's going to be one entry in there for each step. Then we're going to return that. There's a few things we need to do in the middle, so we need to copy right, because if we just do stuff on bodies and just start calling step on it, then we'll actually be progressing the simulation for all the other things, and it'll just like crazily jump forwards in time when we want to keep that previous state and then predict stuff forwards, but then leave that old state there. We're just using the prediction to generate a load of points to draw. And this needs to be a deep copy of bodies, which means, you know, if we have a body contains like these vectors, like the position, it's not enough to say create a body and then pass in that position. We need to copy the position as well, so that this vector itself isn't like shared in the copy of the body we're doing simulation stuff for. So I think what I'll do is create a convenience function here which will do that for us, and then say get from this, and it's going to have a position of so importantly this is copying or cloning that our own position vector, so the clone gets a fresh copy. You know, that might actually do it. Is there anything else? Our acceleration, yes, should be. No, that would do that itself. Let's fix name image. Okay, so if we start renaming stuff, that will start getting corrupted. But as it is, this should do just fine for us. We'll probably tell pretty quickly. I mean, this is the kind of place where errors can very easily get introduced into a program, like because I forget to copy something and then my predictor starts like fiddling with the position of my planets and stuff. Goes really funky. Like this is a cause of many bugs, like situations like this. So we just need to make sure that everything's properly isolated. So we're going to copy this list. Okay, so now I've got our clone, and I think all we want to do is say for try a set number of times. after we've been told, we are going to say step with the clone bodies, and okay. This is that screw up I almost made of that exact same type I was talking about, so when we pass in the body of interest, this cloned bodies is no longer going to contain that, right? It's going to contain a copy. So what I think I'm going to do is say if the equal to body of interest, then so we actually want to be caring about the clone, right? So as we're going through cloning stuff, after we've cloned the body we're like tracking, then we now want to keep track of the clone. So then I can say clone body dot not clone body, but body of interest. Okay. That should do what we need. One thing we probably don't need is to have these things when we simulate doing all of this stuff. It's going to be kind of inefficient. So I think what I do is say have this little flag. So you can say, hey, if we're running in the context of like it's always a simulation, right? If running in the context of a prediction, then we're going to skip over this stuff. So also pass that in here. Yes, we're going to say yes, it is a prediction. But when we update here, it's not a prediction, it's for real. Okay. Don't necessarily know that we need to expose that up here. But again, it's just a quick hack together demo, so probably not an issue. So not actually using this yet, but let's check that this whole refactoring hasn't broken stuff. Looks good to me. So when do we want to do the simulation? So a good time, I think, to do that is when we're placing something down, right? So here, I think. So it might make sense that when we draw this, we want to then There's something I'm considering here, which is that, okay, there's a janky way around this, because this thing doesn't actually exist in the simulation yet. So what I could do is kind of make a pseudo thing for this. Just like this, right? First of all, I'm duplicating this code, which isn't great, but we can fix that afterwards. I can do something like you know what, I can probably make this a bit cleaner. Do something like the bodies don't contain the body of interest. Then I can just add it to our clone thing here. Getting a little bit janky, but I think this kind of should be fine. Yeah, so there might be a case where we're already doing a simulation and we want to predict the path of let's predict path, actually it sounds nicer. Predict the path of an existing planet, in which case this body will already be in this list. And kind of find it here and keep track of it. The other case though is where it's not already in the list, in which case we just add it to our list of clones. Probably don't necessarily need to clone it, but we know in this case it's a throwaway body we've just created, so maybe we can always assume that's the case. This, then how many time steps should we do? Should we say 1,000? I don't know how long that will actually take. Positions would actually predict path. You know what, let's be conservative and say 100 for now. And then shall we let's draw that path. Let's make it kind of blue color. Okay, we may have really screwed something up. This is getting into like creating a kind of crazy graph of objects and pseudo pointery stuff. Okay, yeah, something went wrong there. So maybe turn the debugger on here. See what happens here. The variables on the other monitor. So the initial velocity is basically 0, or exactly 0, that's fine. Body to predict is at a reasonable position. It's a velocity of 0, it's an acceleration of 0, all good. Let's step into this and see what it does. So we should copy all of these bodies. Shouldn't find the body of interest. I'll just add that in here. Clone bodies contains these things. Okay. I'm not sure what's going on. The debugger is really not great in processing. Just took a few steps and see if it still goes quite so crazy. Oh, okay, so this is an issue. Place position needs to get copied. Okay, you see there are so many there are so many things which can get screwed up here if you don't copy them properly. I think that's probably it. Don't know if you can see it. There's some little blue dots kind of appearing on that line. So if I make that longer, should get a better impression. Yeah. And this should even like change as these other planets kind of potentially affect it, right? Because it might be the case that we like interfere with those. I put in. Oh, this is cool. Okay, first of all, let's make this longer. It doesn't appear to be a big performance issue. Whoa. Oh, this is fun. Look at that. Okay, can we get the figure of 8 happening? Have we done it? I think we may have done it, you know. Okay. We can then pause this and try some different stuff. We have one going there, then we try and put one next to it. Is there a way to get them to orbit each other? Yeah, okay, this is kind of what I was hoping for. Get these cool effects where they interact with each other. What might be cool is if anytime I hovered over something, it would predict its path. So, do we do that? Something like... maybe only... you don't have any kind of planet selected. use the same kind of logic. In fact, let's put this in a function. Okay, let's do something here where we can actually just put it out here. Then we can use the same code for both cases. That's interesting actually. Why does it not show the actual path it's going to take? Right? Because we know it's going to continue going around in that circle. So why is the prediction wrong? If I get rid of extraneous stuff. Interesting. So clearly the actual simulation we're doing and our prediction is not giving us the same result. Why is that? Do some debugging again. Get rid of this thing. Predict for this. See if anything funky is going on, like are we somehow adding another planet into the mix? Oh. I think we were. There's something weird here, right? So I think what may have been happening is that when we did this check, this was no longer the case because the body of interest became the clone. It's kind of this jankiness of using maybe a nicer way to do this would be to say this. There we go. Let's make a constant for how many time steps to look ahead when we do the prediction. Nice. I should be able to try adding something in and be able to see the effect of that. Okay, now we can see the Earth. Depending on when in the Earth's orbit I launch, I'm getting a different trajectory, which is kind of what we would expect. So actually what we're doing here, in a way, is more complex than what... Okay, maybe more complex is not the right... This is slightly different to what something like Kerbal Space Program does. I believe the way Kerbal Space Program works is that for any given object, it only applies the gravity from like whatever the most significant contributing thing is, right? So in this case it's the sun, whereas if I'm a little moon orbiting this and I'm close enough to the Earth, I kind of switch over into the sphere of influence of the Earth, and then the sun and these other things are like no longer particularly affecting me gravity-wise, and that allows them to kind of just get a simple equation, or a relatively simple equation, which shows them the whole path of the orbit. But now, because these orbits may be affected by, if they come, if these two planets come close, they may get shifted out of alignment. There's no longer like a really simple single equation which you can just plug in to get their positions. You kind of have to do this simulation to figure it out. So it's kind of more accurate, but it's also less stable, and things tend to like fly out in crazy directions, as you might expect. Also pause this and then try to add Okay, so I think the last thing to do, which might be cool, is to add some sort of player controllable craft in here. So I think what I want to do there is to take one of these images. This should do. Yeah, we're still going. So I'll show you where we got to so far. So we now have this system where I can go in here, I can kind of delete these objects. I can add in new planets and it will kind of show me the predicted orbit of these things. So kind of inspired by Kerbal Space Program, so I can set up an orbit like this, for example, and then watch it go off. Yeah, this is kind of epic. I really like the kind of predicted path thing that you can do. I can delete some of these things. I can do some other cool stuff, like I can send this flying. I can then pause it. I can start placing another planet nearby, and I can see possible, if I give it different amounts of speed, like what it's going to do to their path. That's kind of interesting, right? Like I've got this thing where these things have two crazy paths like that, and then you can kind of watch it unfold. And they'll kind of go along the paths that have been predicted. And the way this prediction works, it's not doing anything super fancy. What it's really doing is it's actually just creating a copy paste of the whole little universe and then just running the same simulation like a couple hundred or 1,000 times, and then just plotting a line ahead showing like where these things are going to go. Do some other interesting things. Like I can now drop my 2 planets down here, or 2 suns, sorry. I can then try and add something in like this, and try and figure out the path that will give me like a figure 8. Boom. Yeah, and the last thing I want to do before the end of the stream is I'd like to be able to have something here like a little spaceship where I can actually like have thrusters on it. Oh, that stuff's coming back. Let me just delete those. Yeah, I'd like to be able to control something and then... Is this realistic? Yeah, I mean, this is using the basic formula for gravity based on the mass of these things and their distance apart. You know, the actual speeds these things are going and how big they are and how much mass they have is not necessarily realistic, but the core of the math is there. We also did a load of stuff to make the simulation like reasonably accurate. Like it's not, you couldn't use this to plan mankind's trip to Mars, but for like this kind of simple setup, it's definitely kind of viable. Yeah, so it's kind of accurate and it's based on like actual fairly legit physics, I can say. Oh, this is cool. So what we're seeing is if I release this at a different time, it's going to interact with... You can't see what I'm pointing at. If I release this one at the bottom at different times, it's going to interact with the orange planet that's already there differently. So you can see how that will affect my orbit. Like if I do it at the wrong time, it can get kind of flung out because they'll interact in weird ways. So even though I'm not moving, the prediction is kind of changing based on when I release this thing. Yeah, so let's get the spaceship going. So there's a couple of things we need. So what I think I'm going to do is add a new class here, call the rocket. Cool. Yeah, I mean, if you have any questions, I don't know how old 8th grade is. We don't have that same system over here. But yeah, you talked about Scratch before, right? Like, if you're interested in this, I'm always happy to talk and kind of answer questions. And hopefully this is kind of step by step. I try and explain stuff as I go along, but I know sometimes it won't always make sense, but we shall see. Oh yeah, okay, England. So what's 8th grade? Well, like year 8? Okay. Is that the same thing as 8th grade? No. What about my accent? What do I do I sound American? I don't know. Cool. You know what? I'm not going to create a separate class for this. I'm going to do something a bit different. And I'm just going to say have this kind of controlled body, if you like. And what I'm going to do Okay, first thing is I kind of want it to... Oh, you know what? Okay, I will add another class. Images of planets. Oh yeah, I'm a big space nerd. Yeah. if you didn't realize, I'm kind of into this stuff. I have some other spacey things around. I have some astronomy books over there. Yeah, this is my jam. I've actually made this kind of thing, to be honest, a few times in different languages. It's one of the kind of projects that I'll often play around with when I'm learning something, because you can get something relatively cool up and running relatively simply. What I've never done actually though is this whole like prediction during the future paths thing. So that's kind of new. Space is crazy. Like if you think about it, it's kind of terrifying and immense and kind of unbelievable, really. So I always forget in processing if I can tell when a key is being pressed down or not. Yeah, this is kind of a janky thing you have to do. So when I thrust, I always want to thrust in the same direction that I'm already going, basically. So when we normalize a vector, what that essentially means is setting its length to 1. So if we've got our little ship, moving like in this direction, maybe that's like 10 meters per second. And if we just care about the direction and not so much the speed, then we can just, what we tend to do is clip this length down to 1, because then we can scale this back to whatever other number we need. So what we're doing is getting a copy of the direction it's going, and then we're scaling it to 10, which is just kind of just calling it the thrust force. Okay. Yeah, doing is kind of dumb. What I want to do here is say if where I press up, I want to start thrusting. This is one of my frustrations about processing, is I don't think it gives me a way to say right now is the user holding down the up arrow or not. I have to kind of keep track when it's pressed and released, which is really not ideal. How many languages do I know? That's a good question. So probably quite a few. I mean, like once you get into programming, you start picking up new languages like pretty quickly. Like I was saying earlier, I started playing around with Golang earlier this week, and I'm still definitely a beginner in it, but it was within a day that I was actually making stuff with it. So the stuff I initially learned was, I did some like Visual Basic like a long time ago. That's maybe one of the first things I did. There was something called Dark Basic, which was like a game programming language from like the 2000s, which I played around with. So this is like my early days, right? Yeah, maybe those. And then at some point I was playing around with Java. Then I went to university. I probably probably did a bit of like C++, but like never really got into it. University we did more Java. I learned Python. Anything else we played around with? I didn't really do any functional stuff. Did a bit of C. And then in like the world of work, stuff I've been paid to do. I've probably SQL, Java. I've done a bit of C, Python, C#. That's used in Unity for game stuff quite a lot. HTML, JavaScript, so TypeScript, which is more or less related to that. There was something called PLSQL, which is like a database programming thing for Oracle, pretty old school. Just for fun, playing around with Go. Yeah, maybe I'm missing something. I feel like these are the languages that I'm actually like comfortable with, like relatively speaking. Which is what? How many? Probably 10 or a dozen. Yeah, I mean, do you count CSS? I'm not a huge fan of like front-end web stuff. Honestly, I'm more a fan of like back-end stuff. Oh, also like Bash, like Unix stuff, Unix stuff. Trying to think if there's anything. Basically, it's like you learn a new language when it seems interesting to you, when it seems like the right tool for the job. Like, it used to be we want to write on Android, you have to use Java, but now there are other ways. Actually, I've done a bit of Scala. But you want to make Minecraft mods, you have to learn Java because that's how it's done. The thing is, once you learn one, like learning a second one is really not a big deal. It's mostly a case of you know what you want to do, you need to look up how certain things differ. Sometimes a language will like have a totally different way or a significantly different way of doing things. Like Go kind of has this, and it makes you think, and you're like, oh, I have to change. I can't just translate the way I used to do things in another language. But for the most part, all of this stuff, it's all transferable. Like once you know one, once you know programming, then it's kind of all the same. I mean, some of them are exceptions, right? Like HTML is not like programming. It's kind of something different. Yeah. What was I doing? Oh, I was wiring up this thing to do this thrust. Okay. So I think what I want to do is if yeah, that's true. I mean, I feel like the first one always takes years to learn because you're learning not just programming, you're not learning not just the language, you're learning the actual way of thinking of programming. And all of this stuff like ifs and loops and stuff, it's once you've got a handle on that, it's like it's way easier, if in a different language, if this is if this is some other way of writing the same thing and I have to write like if I have to do that, then that's a different programming language, but it's the same thing. Yeah. Okay. Kind of going to be a bit janky, I think. There's the rocket. Okay. So what I think I'm going to do is when I place something, if this is kind of a hacky way to do this, if it's the first thing in our little list, we know that's the rocket. So whenever we add a rocket, we kind of make that now the thing we're controlling. And then in here, I'm going to say control body to the null. What I should probably handle is I can delete something by right-clicking. I probably want to say if I deleted the thing I'm controlling, then I no longer want to be controlling that invisible ship. Yeah, I mean, actually, this is less organized than I would like it to be. I try to name... I care very much about naming things properly. Actually, like, organization-wise, like, what I don't like is the way I'm deciding I want to control this rocket, and I'm just doing that by checking that it's, like, the first thing in this list, which is not a nice way to do it. I should have extracted that away. I started doing that here, but then kind of changed my mind. So organization is not that great, but I care very much about naming things so that it's like relatively obvious what's happening, right? Like I could have called that like Acume Grav, but that's not my kind of style. I'm more likely to give it something that's long and long-winded, but it's a bit more obvious what it's doing. So it then means that when you read this, it reads a bit more like plain English. I mean, it's not quite there, but you know, you have a better sense of what's happening. I tend to throw a load of stuff in one file or a couple of files when doing these streams, whereas in reality I would separate things out a bit more. But yeah. So let's see if this does anything. So I can place this little rocket. Now I believe that if I hold thrust, then it should thrust, right? Hey, I think that worked. There's a couple of things I want to do. I want to say so you know, if I'm like hovering over something or placing something new, then it becomes the thing I'm predicting. Otherwise, I want it to like fall back to showing me the path of the thing that I'm controlling. I kind of want that to always stay on. Right? So you can see the path there. If I hold up to thrust, okay, see the path changing. That's cool. I'd kind of like to also have like a some terrible naming. Like for like thrusting backwards. Braking would be would be the more sensible English. Anti-thrusting. What am I thinking? It's getting late. You're right, I've been streaming too long. Okay, where are we? So thrusting, if you're thrusting, then it's going to be forwards. So that should allow us to brake with the down arrow. Hey, we've made Kerbal Space Program, right? Like, there it is. Okay, void means that something doesn't return a value. So, for example, when we tell the simulation to like update, to like apply a sort of round at the simulation, it just does it. It doesn't give us anything back. It just sort of does what it needs to do. But when we tell it to predict something, it gives us back this path of predicted positions. So then, rather than a void, it has something specific. It's something specific that it like returns back. In other languages, that just wouldn't be there, but it's just how it works in some, several languages work like that. It basically means nothing. So when the mouse is pressed, you don't return anything. You just say it's void, and then the function ends. Otherwise, something which does return something. Like this has no return statement, right? Whereas this like returns a result. So you need to tell it what type the result is. Yep. Okay, what else do we want to do here? Okay, yeah, I wanted to rotate the body to face the direction it's going. So I'll probably add something here. Not the nicest name. So now I want to say rocket fixed. No. Should the rocket rotate? Yes, it should. Nothing else I want to rotate. I'm going to set that to false. Yeah, void's a weird word, right? Like, it's like the void, like the darkness of the void. It just flies off into nowhere. There's no result that you can catch. Kind of how I think of it, I guess. I'm sure there's a more reasonable reason why it's called that, but it's kind of a scary sounding word. Okay, so what I wanted to do is when I draw this, I want to say the abyss. Yeah, it should be called abyss, black hole. So if we want to rotate, then I'm going to need to do some fancy stuff, otherwise I'm just going to draw it as is. So the way we do this is, it's just a quirk of how graphics rendering works, so I probably wouldn't worry too much about this. I have explained in previous streams what this does. Basically what this will do is if that rotate flag is set, it will draw our... Oh, we can clean this up. Basically there's a quirk where if you want to rotate an image and draw it, then you need to use this form of like drawing it at 0, 0, but then translating it and rotating it from that, because there's no convenient way to just draw it at a position and rotate it at the same time. Let's see. Okay, we're just off by 90 degrees. So we will just rotate this around. Something weird happening there. Oh, okay, that's why. Okay, so there's our lovely sun. I can place down my rocket and it will fly along its path happily. I can do some Kerbal style orbital adjustments. Put myself into a circular orbit. And then create something else. Whoa. Can we save ourselves from this situation? Yeah. Oh, this is fun. Except we're about to fly off into the void, so let's try and pull ourselves into a sensible shape. Yeah. So the crazy lines are because if you get too close to something, you get kind of slingshotted off and you like fly off into nothingness. Three suns. Yeah, I wonder if we could do it like... Oh, can we get like a three-way... Oh, this is so fun. Oh, I think we may have done it, you know. Is this a stable arrangement? Oh, not quite. Let's... It's amazing as well how like a tiny adjustment in thrust can have like a crazy big effect on where you end up going. Yeah, is this line gonna loop back around, or are we gonna be in a bad spot? Yeah, it seems hard to find like a... I'm just trying to find a path that like just does what we want it to without having to make adjustments, so I'm making little thrust adjustments here. Okay, the line becomes dotted because we're actually only calculating with like fixed steps in time, right? So if it gets faster, like if I do something which will send me flinging off, then what's going to happen here is that it's going to come around, it's going to get real close to this, and it's going to get flung off super fast, which means each second or each like frame, it's actually going to move so fast that the line becomes dotted. I could draw it just as a line, as opposed to a set of dots. Like that would be very easy to do. But I kind of like, yeah, you see what happened? It just got flung off. I kind of like this because it's, in a way, it's more accurate to how the simulation is actually working. What else can we play around with here? Yeah, if you have any arrangements to suggest, I'm definitely open to that. 3 suns like this. Trying to think what we could do here. Oh, nearly had something. Just tweak, tweak, tweak. Yeah, basically, exactly that. This is also chaos theory, right? If you heard of chaos theory, it's like I'm making tiny, like 1 pixel adjustments, and that looks relatively smooth, but then, oh, I'm off, right? I get flung off into space with that path. Little adjustments, so finding the right path is kind of tricky. That might be it. I might change this to simulate more steps in advance, but yeah, I made an ampersand. Okay, we better accelerate. We're going to get hit by that. There. It's kind of interesting, actually. I can imagine a game where there's like pickups you have to get, and you get put in a certain arrangement, and all I can do is like thrust a little bit and try and not get gobbled up or flung away by one of these suns. Well, this looks kind of stable. See, I get worried whenever it goes too close between, because it ends up in, yeah, coming back like super tightly. That's not ideal. Let's leave that rocket flying and we can put another one in there. That's a kind of cool pattern as well. Yeah, I think you need to get stuff really precise to get a perfect, like, clover-shaped kind of thing going on here. Yeah, but I mean, the code so far is definitely working, right? We definitely end up following the path it predicts for us. One issue is that this is done in a quite an inefficient way. No, I'll leave this running. But when we calculate the gravity, we're looking at every planet and comparing it to every other planet. So, you know, if we add 1,000 planets, then that's 1,000,000 gravity calculations going on. And there are ways to kind of improve that, but it works really nicely for like low numbers of things, but if we increase that, it would start to run slower. Although right now, honestly, probably the drawing is what's slowing it down more than the calculation. Let's throw a wildcard in here. Okay, this is pretty sweet. So a couple of little tweaks I want to do. I want to... Okay, yeah, please go ahead. I'm always open to suggestions there. Oh, you know what would be cool? We could try some like Kerbal type maneuver. I have to make a game in 2 hours from scratch with the whole team. Okay, that'd be kind of crazy. But possible, you know, I think that kind of thing could be done. Okay, so what I'm thinking now is, can I have a ship which will orbit this little planet? Oh, 3 hours, okay. Yeah, so we have done some game jams before. So we did the LD jam a while back, kind of as a team. Yeah, 2-hour game jam. That would be interesting. I could orchestrating it and get it, because our team is kind of spread across the world, in America and Europe and in the UK. So getting everyone on at the same time would be kind of difficult, but I think that would also be super fun, to be honest. So what I'm doing here is I'm just bringing down the speed with which I launch stuff, so I have a bit more control and finesse over it, basically. Then I want to add this planet here. Okay. That's orbiting. Now I think, can I get my... Oh! Oh, that's cool. Someone made a 2D Minecraft in Scratch. That's awesome. Okay. Okay, I wanted to be orbiting this other planet, but we're kind of there. I don't know if you'd call this an orbit, technically speaking. But now that we're orbiting this thing, is it going to be possible for us to break out of its orbit? Maybe by slowing down. It's crazy, right? So what I'm hoping to do is to kind of break out of the influence of this planet, start orbiting the sun instead. Okay, and then bring that back in. Yeah, we're gonna have a near miss here. So compared to yeah, right. So compared to Kerbal, this is going like really fast, which I think makes it a bit harder to adjust your trajectory. Okay. So I think the issue of why this rocket is going so crazy is because this is still influencing it quite a lot. This is quite heavy still. So the gravity force from the orange planet is also high, so it's never going to get into like a really stable orbit. What if planets could crash? Yes. What if planets could crash? That's a good question. Can I make that happen in the last like 10 minutes? Maybe. First of all, I want to crop them so I can tell how big they are accurately. Hmm. So, what happens when things crash? So when two spheres hit each other, you have conservation of momentum, mass, so they have a velocity, so VA MA plus VB MB. Oh, to have them kind of break in half. Okay, yes. Chunks. Okay. So let's add a little fragmenty thing here. Is there something I can take from this? Yep, let's let's just like slice off a chunk here. That'll do. Okay, so I'm changing now from a void to a boolean because I want this to return true if there's a collision, then they should be destroyed. Nice way to do this would be to like have the chunks generated from the original planet image automatically, but it's kind of a bit much, so I just picked a generic bit of shrapnel we can use. Okay. we can figure out how many of these things to spawn, I guess, based on their mass. So let's say something like that. Um, okay, this will probably cause stuff to go crazy. Oh, okay, got something wrong there. Really need sound effects for this, right? Oh, that did not happen. Ah. Whoa. Okay, that was kind of crazy. So I'm gonna add a flag. Oh dear, yeah. Also, when we do predictions, I'm gonna say e.no. We can ignore these in our like little future simulation things. Also in here. I mean, again, this is not the nicest way to define this. I just kind of hacked it in to get the feature working. But basically, we're seeing a point where the frame rate like tanks a little bit. So I kind of want to pull these things out of certain calculations and not render the trails for them because yeah, it's a bit much. So now we have space junk flying around. So there's actual issues with this, right? This is actually what happens when like satellites smash into each other. They just go into like millions of little fragments and then pollute the whole thing, and then if anything else touches them, then that explodes as well, and it creates this crazy chain reaction of like satellite fragments, which screws up the whole area like around the planet. Did I get an error there? See if we can smash these into each other. Whoa. Whoa, this is weird. Okay, so I think what's happened is these chunks have started spawning their own... Look at that. Oh, this is nuts. Oh no, okay, it's because this orange planet is so heavy, I was changing the number of these things which get spawned based on how heavy the planet is, and this planet is like 1,000 times heavier than that Earth, which is why this has happened. So let's stop this from happening. So let's say no more than like 20. If I can get these to hit each other. Looks like it's happening. Boom. Cool. This was like a Zen-like little game, and now, now you've turned it into something altogether different. I like it though. I'm into the exploding planets. Yeah, so I think we're about done for today. This was genuinely a pretty fun little project. See, I've spent far too long playing Kerbal Space Program. This is entirely the kind of thing that would suck me in for hours playing around with it. Splat, right? Yeah. Yeah, it's really cool how such a simple, well, it's ultimately a very simple little equation for this gravity stuff can produce all of these crazy, crazy patterns and effects. It's kind of infinite complexity that comes out of this super simple basic premise. I've always loved like simulations in terms of stuff to do with a programming language or a computer. Like a simulation is always something super fun to me because you can make something with simple rules and then it can do stuff that like genuinely surprises you, which is hard to find in other jobs, I think, right? Like that you can make something and then it can totally surprise you, like what it actually does and how it behaves. I thought that's something cool and interesting about coding. Let's make our final little solar system here. Okay, I'm just fiddling now. It's time to wrap this up. I almost forgot I was streaming. Okay, thanks everyone for tuning in. I'm going to drop our usual links here. So there's our Discord where you can join our playtesting group for Steamhounds, which is our main game project. We're running a tournament tomorrow evening, so please come check that out. That will also be streamed here. If you don't want to participate, you can at least tune in to watch. And here is our Twitter, where we post kind of regular updates if you just want to kind of follow along. So all the streams are announced there. We post polls there for coding stream topics. Yeah, no, thank you. It's been fun. I've really enjoyed this. Like, I've made a toy basically, and I could sit around playing with this for far too long. I have to force myself to stop and eat some dinner and that kind of stuff. Okay, thanks everyone. I will say goodbye, and I will catch you next time.